It's been a minute, but here's a cool library that I'm starting to use quite a bit, and that is the macro rules attribute. And what that allows us to do is to define our declarative macros and then to use them to decorate our type, like so. So we use the apply and then our declarative macro. So it's not to replace proc macros, which is good when we want to have more complete things, but for simple use cases, that can help a lot. And in fact, one thing that I use that a lot is to help with my derive. So this way I can consolidate them. Now, the trick here is how we define this one to be able to do that. They even have a simpler option over there, which is a very cool one, which is our derive alias macro. And then we do our alias like so, and then we can say what it maps. And we can even compose them. So it's super powerful. And then in our struct, we have the derive, which it's the one there. We can put normal proc macro derive, and then we can have our aliases like that. And it's super powerful. And so this is so cool that I'm planning to use it for most of my projects. And here I'm going to show you a real concrete example and some of my best practices. So first, we're going to add this here, the macro rules attribute, the 02. That is my little way to do my sections over there. And now to understand the example, we're going to go to project. And this is just a simplistic skeleton of type of projects that I have. And so I have the fields, some proc macros over there to allow me to take from and to sequence and so on. And then inside this project, I have properties, and then I have two types, the ID and the epoch US. And both of them are actually I64. But the point here is I want to type them such as my code base is typed, and I know what type of I64 it is in a way. So it's just wrapper types. So if we go to ID, I want the ID to behave mostly as an I64 and to have all the compare and all these kind of things. So the way we do that, obviously, is with the derive, and then we have this long list here. And then we derive the derive from into display, deref, and then some SQLite or ModQL or whatever you are using. So this is what we're doing, but then when we have another type, for example, epoch US, we have to repeat that again, all these kind of things. And so not only we have to copy paste, but then if we need to maintain it, or if we decide to use SQLX or CAD or whatever, then we need to add everywhere. It's kind of a pain to maintain, and it's not very normalized. So one way to do it will be to have a macro rules here that will wrap the whole things, but then everything is wrapped into a declarative macro. So that's not super cool. So my best practice now is the following. Let's do that. And the first thing that we're going to do is we're going to go to our main. And the way that I like to do it is I'm going to do a mod derive aliases. So that is going to be my derive aliases for all of these submodules. So basically the crate one. And I'm going to export it as private to this crate. So use derive aliases and start like that. So now I'm going to create this file over there and we're going to get into it. So the pattern here is when I'm going to see derive aliases is going to be all the aliases that I can use for that modules and anything below. So that is the goal of the design. And sometimes for some layers, I might have other ones that might compose this one in some layers below. Not all of the layers, but for example, for model, I might have derive aliases that are just for those guys. So I don't want to put them everybody at the root. So that is going to be the way it works. So now what I like to do is in my derive alias, I do like that. I import the macro rules attribute derive alias. I could do the XNR macro over there, but I like that way. And then we have the derive alias, and those are the two aliases that we are creating. So that is the syntax here to create our alias, CMP and hash. So CMP will expand to that, and hash will expand to that. And we can actually compose them, which is very cool. Now, one thing you cannot do, and which is fine, is you cannot add both CMP and hash to the same derive because they are going to conflict on those guys, which is fine because if I use compare and I want hash, I just add hash to that. And this is why the downstream aliases that we're going to see in model are going to take care of that. And usually also I have some other one about enum as string or this kind of things. It could be very useful here across our project. Now, what I'm going to do is I'm going back to ID and I'm going to add, rather than these four guys, we will be able to do a crate, CMP, something like that. Now, if I press save, it's going to complain because the standard Rust derive doesn't support these kind of things. So this is where my second best practice comes in, and that is to import the macro rules attribute as MRA, because this one is way too long, and I want to make the distinction between the standard derive and the macro rules attribute derive. So that is the way I like it. And now it works, it compiles. And if we do a cargo run, that should work beautifully. So now I like to have this one not fully qualify, but have it there. So that is the way I like it. So something like that, that works very nicely. Now we could update the epoch macro second over there, but we're going to wait a little bit because in fact, what I would like to do, usually in this project, model is big enough that they are going to have their own set of aliases. And the way that we do that again is mod, derive, aliases. So I have the same name all the time, such as it's super simple for me to see which aliases I have for the module and down. So that is a way. And now I'm not going to do a pub use because I don't want these aliases to bleed up. I just want to have a use, derive, aliases, and I do something like that. So that is what I like to have. Now we're going to create this file over there. So that will be our skeleton, same pattern. And now the aliases that we're going to create is going to be the derive, and a name that I like is scalar struct. So that is for the scalar type for my database and my model and everything that are struct based, usually tuple struct. So I have this one and I'm going to do a equal, and those are going to be expanded to derive, and that it will be the list below. It will be a multiple list. Now the question is, what do we put there? So I go back to my ID and I want to have everything. And as far as my best practices, I don't like to have the debug within these aliases. The debug will be something out of the alias all the time. And I'm going to take all of those guys over there. And then I'm coming back there and I'm going to put that there. And so now we have all these kind of things. And this one, actually, when I am in the derive alias, I like to have the fully qualified name like that. So I press save. So now this is a way that I have my aliases. That looks pretty good. And now I go back over there. And then here I can put a scalar struct, and that will do the right thing. And in fact, I will probably put that there, something like that. And this needs to be something like this. And that works very nicely. So now it's short and sweet over there. I know what I have is debug and a scalar struct. Very nice. I have my type over there. I can even have the autocomplete. And those are going to be all of my type. I'm going to have a scalar enum as well, and all these kind of things that can map to my database and so on. And so now that we have this, we can actually remove that and then press save. Works nicely. Take that, and I'm going to go to my epoch guy. And then I'm going to paste it there, and that should work very nicely. And then I do a cargo run, and then that's it. So that's my best practice, yeah? I have these derive aliases now that I'm going to re-export from the main module, from their parent modules, as used like that. This one, I have it that. Inside, I put the aliases that make sense to have at this level. And then I can use the aliases like that with a nice name. And then I make sure that I have the MRA, such as I know that that's not the default derive. And that's it. That is my best practices about this. Okay, so now the very cool thing here. If you're okay with AI, let's go back and we start from scratch. So again, we have our project over there, but now our ID are back to square one, all of this. But we can use AI to follow our best practices, even if AI doesn't really know this great. So here's how it works. So first you go and you install AI Pack, and you can install it on Mac, Linux, or Windows. So it's just one binary, everything is included, and it's fully open source. Some cool demo over there. And this is one thing I built fully in Rust. Then what you do is AIP check keys to make sure that you have your keys. So we have all these keys because I'm using all these keys. So AI Pack just talk to whatever model you want with your keys. And then you can install packs. Right now there's an AI Pack install Pro at Coder. That is a Pro Coder pack. And then AI Pack install Pro at Rust 10x. And that is my Rust 10x best practices. Basically, all of the best practices that I put in the videos, I'm putting it there. So there's quite a bit and more coming. So we're going to install that. And now we can do an AI Pack run Pro at Coder. So AI pack run procoder, you go there, and now you have this kind of things. So that is a parametric prompt. And so what we're going to use is, as a knowledge, we're going to use our Pro Rust 10x guide base. So that's the way to use that. We can use absolute path, relative path, or other packs. And then we have our base dir. Then we have our context. We're going to put the cargo because that is actually useful. And then our structure globs, which will be just the file path. And all of that allows us to fully control what we're sending to the AI. So compared to other tools, here we have full control. A little bit more work upfront, but much better result down the road. So that is for concurrency. That will be for later. And now we're going to have the write mode true. And now we can use either codex, GPT-5. There's plenty of aliases over there. We can even control the reasoning level with suffix. So we could do a GPT-5 mini high, for example, and that will work very nicely. We're going to try to use the Flash, and the Flash latest is pretty good at coding and is much faster than GPT-5 or codex, but you could use also codex here if you wanted. That will work pretty well. So we're going to do a Flash for now, and we're going to do a prompt like following the Rust 10x best practices, implement the base root, derive aliases for this project, and update the ID and epoch US. And we're going to say, do not implement the model, the aliases yet. We go back there, and now the terminal is built in Ratatouille, Rust, super interactive. You can press R or even mouse over and then press R there. So things are pretty interactive. You have the task. Sometimes you can have multiple tasks, and then you have the overview of the whole project. So here we see 7 context files, which makes sense. And then we have 10 knowledge files, which makes sense. It's our knowledge over there. And then so on. And we have a concurrency of 1 because there's only one task. Okay, so we see the size we are going to send, and we will see what it replies, and we see the models that we're using. So we're going to wait a little bit. Boom, done. So Flash is a pretty small model, but it's actually, when the instruction is good and stuff, it works pretty nicely. And otherwise you can go on to codex and stuff. And this is pretty cool. It implemented this kind of guy, which is part of the best practices, but I can implement my own later, and is adding it to my main, is doing these pub things, is following the pub error here. So to be honest, I'm not too mad at it, but because I am on a crate, I don't really need to have this use, so I would do something like that, or both of them. So usually we don't do a pub, but because you had the pubs here, kind of follow, which is fine. And then I have my derive alias, and then if I go to my things over there, it did follow the pattern pretty well. Use crate and stuff. And now if I run something like that, cargo run, everything works. And then I'm going to try these pretty cool things. If you go there, kind of suggest kind of a git commit. So you click to copy, go back to your terminal, click, boom, done. Now that we have this, we're going to go back to our coder prompt, which is over there. And we're going to say, now implement the derive aliases for the model layer. We're going to say scalar struct for the derive of epoch US and ID, except the debug. Okay, so that should be pretty good. And you can go here, press R, and that will do. So while it's doing that, you can actually navigate everything. You can even cancel the run if you want. So here you can see the times that is going over there. And we have a little bit more files here, same kind of files there. So far so good. You can change, if you have many tasks, you can have a grid view, which is pretty nice. And then you go there, and then we're going to wait a little bit. The last one cost us 2 cents. And that is quite a bit of reasoning for things, but makes sense. And look at that, derive alias, all of that is pretty cool. So this is done, and this is done. I'm pretty happy. That is because I am OCD, and I'm going to go back there, and this one is done. Let's save it there. Pretty good. So sometimes you have to do, it's good to do a cargo FMT if you have your FMT somewhere, and then you can actually go there, click, go back there, paste, boom, done. And that is pretty cool. Until next one, happy coding.